1:31. I just need to quickly do a couple of things. And yeah, thank you for your time and for waiting. And yeah, we'll get started shortly. All right, so you guys should be seeing something, hopefully. Um, yeah, okay. Right. So if you guys are seeing something, okay, great. Thank you very much. So it should be a coding screen. Yeah, hopefully it is just that a coding screen. And we will get started using that. Okay, so today the lesson will be on, yeah, thank you, Athvan. It is indeed a replet. So yeah, today's lesson, the first one of four. So after this one, there's going to be another lesson. And yeah, there is a Kahoot later. Um, so yeah, it will be on implementation and optimization, right? So implementation optimization, they are things that are very important when you're coding. And no matter what code you kind of write, implementation will always be an unavoidable part of your work. So don't worry, Athvan, we will send out the Google Doc later so you guys can follow along. But yeah, right now I'm just gonna talk a bit about the introduction. So what is implementation, right? Well, you have been doing implementation all along whenever you code, because it's just when you carry out a plan, or in your case, when you just do the actual programming for your code. Now, if you have been doing it all along, why would I be talking about it, right? Well, because there are strategies that you can make use of to make your time implementing easier and more efficient. So this lesson is going to cover some basic strategies to use during implementation, and it will include an introduction to optimizing your code, which is also very important when you do implement things. So if you continue on and go to some of the following lessons offered, you'll learn more complex algorithms and data structures to use while implementing. But just remember that regardless, everything falls under the big umbrella that is just general implementation. Now, a good, bit of implementation has four major parts. There's the reading part, there's the defining part, the executing part, and the compiling part. And hopefully they should go in that order if everything goes smoothly. So now I will
Yang,
cover the
sorry
first
to
part,
cut
which
you
is
off a
reading.
little bit, but just so you know that we can see your entire screen, I think in Zoom you can share like specific applications. So if you want to just share the replet, and Also, if you want to post the check-in code in the beginning so the participants can put in the check-in code and get their points, they can do that right now. And yeah, just letting you know.
Okay, yes, thank you. So something weird is going on where like when I talk, there's a delay and then I hear the talking again. So all right, yeah, I will post the check-in code though. Oh, and I'm sharing my entire screen.
Yeah, if you go on Zoom, you should be able to like stop your screen sharing, and then when you screen share again, you should be able to select specific applications to stream. So you should be able to stream like just your Google Chrome.
Okay, now
Yeah,
it's only sharing
there
one,
we
right?
go. Yeah, perfect.
Okay, cool. Sorry guys, this is like my first time doing this. Sorry for the difficulties. But strangely enough, I still hear like the repeat. I feel like oh well, it doesn't matter. Like I'll just ignore my own repetition. Okay, so we'll be covering reading right first, and that is the first.
You
Yeah.
might be hearing your voice from, do you have the stream open? Like on YouTube or something? That might appear.
Oh, okay. That's probably why. Jeez. Okay. Sorry, guys. Now we'll properly get started. Okay, yeah. So as I was saying before, sorry, I got sidetracked. A good implementation has four major parts. There's the reading, the defining, the executing, and the compiling. And we will go through those steps in that order. So first we will go through reading. Now, the most important part of, the implementation process is, just the reading, because after all, that is how you will know what needs to be done for your code. So when you read a problem statement, you need to take your time and read through the entire thing and make a mental note of important details. Now, this lesson covers competitive programming. So that's talking about when you have to, like, it's competitive programming, right? So in that case, um, you're given a problem statement and you have to code something to solve that problem. And in that case, reading is extremely important. All right, yeah, I see in the chat that the code is wrong. I will now get the actual code. Okay, yeah, all right, I found it. So here is oh yeah, it's already been posted. Okay, well, I guess I'll just post it again. Right, thank you, Lily. Sorry. Um, so yeah, back to the lesson. Yeah, in competitive programming, you need to keep a mental note of important details. And these details include the amount of storage you will be given, how large the test cases will be, and other quantitative, so like information relating to numbers. And usually these are presented after the bulk of a problem statement. So um, most competitive programming problems will start with a kind of story and mostly useless details. And these useless details are called red herrings, and they won't matter later on in the implementation process. And these usually should be ignored. So common red herrings would include the name of a character. So like, maybe the question is like, oh, Bob is trying to cross a bridge, right? In that case, Bob is not an important detail. You don't have to pay attention to it. The setting is also, like Bob is trying to cross a bridge. That doesn't matter either. The plot, same thing, right? And basically any non-numerical or qualitative descriptions. So like, oh, it's a shiny bridge or something. That doesn't matter. So if the problem is about finding prime numbers, for example, chances are that names of people aren't going to be important. So if the problem was about how Bob wanted to find some prime numbers and it was like a sunny day, then you do not need to remember the names at all. However, there are some cases where names might be important. For example, if it's a problem about like matchmaking or using letters, names will be important. Like last year when I was in computer science class, we had to create a piece of code to match pairs for like a tournament style kind of thing. And in those cases, the names are important, but usually it's pretty obvious the context, and you can usually just figure out what pieces of information are red herring. And so red herrings should be ignored. So the second stage is defining. And this follows right after the reading. And this stage is one of the simpler of the four, but it's also when you actually need to start to code. So say there's a hypothetical problem that we'll be working on. Something like maybe Bob, yeah, we'll just go with the old example. Like Bob is trying to find some prime numbers, right? And it's a sunny day. Well, Bob and the sunny day information don't matter, but the prime numbers kind of do. And say the problem is like you will be given like a certain number, and if it's prime, you print out that number, and if it's not prime, you find the next closest greater prime number. In that case, you would have to start defining some things, because problems, they always give you information in the problem statement, and defining is an important part because it helps you transition from reading the question and understanding the problem to actually putting out a solution. And an important part of this is a good name for your variables. So you want to make sure that your variable names are short yet also meaningful, and you want to be able to type out a variable quickly, but you also want its name to give you an idea of what the variable is for. So you should try and avoid, when you're implementing, one-letter vague names, because these will confuse you later on if your code gets complicated. And personally, I like to keep my variable names as something similar to the first 3 or 4 letters of whatever the variable is being used for. So for an example here, right? I will, yeah. So if I have a prime number, like 13 is a prime number, right? So I declare prime equal to 13. I could also just chop off the E to make it 4 letters, or even chop off the M to make it 3 letters. But if I just named it P, right, that's very confusing. And later on in the problem process, if it gets really complicated, I won't be sure, what does P stand for? It could stand for all kinds of things like pepperoni, plate, plane, like the thing in math. So we want to make sure that at a glance, we can kind of tell what the variable is for, and also that it's easy to type out. So you don't want it to be too long, like prime number holder. And yeah, and in this case, you can also, like, if you had to like keep track of 2 prime numbers, right? Like 17 is also a prime number. So you can do prim2 equal to 17. And then, at a glance that you have 1 prime number and a second prime number there. PN would work. I mean, it's all about like you and like how, like if the code makes sense to you, right? Like technically, if you could work with just like something like P equal to I think 41 is a prime number, then yeah, that's fine. But the thing is, like, if other people are writing your code, so if you're working in a team to do a team-based problem, or if you're looking at older code, you might not understand. But like if you have a convention, like you always use P for prime numbers, then I guess it's fine. So yeah. All right. So it also matters how you store your code, right? I mean, not your code, sorry, your variables. So like with numbers and prime numbers, it's pretty obvious that you should store them, just as a number. But with other pieces of information and in certain, scenarios, it might be important how you store it because you could, store 13 as an integer, or you could store it as a string. Well, in this case, I stored 17 as a string. So the difference here is that you can't do like mathematical operations anymore. So if you try doing like prim plus prim2, then like it wouldn't work because you're trying to add an integer to a string, and it's always important that when you're performing like an addition, that both sides of the addition sign are the same type of that like information. So because prim is an integer and prim2 is a string, adding them together should throw an error. And yeah, as you can see, the error says unsupported operand for int and string, which means that Python is not okay with just adding integers and strings. Just a quick check-in with everyone. Like, do you guys understand this? Like, were you guys taught this kind of stuff? Because yeah, okay, great. So yeah, I don't want to spend too much time like reviewing this stuff then. But what's your like general understanding of Python so far? Or rather, have you guys done like competitive programming like problems before? Okay, well, in that case, I'm going to assume that you guys know a good amount so far. So we'll just continue on because some of the examples here. Okay, yeah. So some of these examples are just to like refresh Python like understanding. Like one of the things I have here is like how would you store a bunch of names? Like in a problem, right? You have like the names of people and you have to write a program to like match pair them up. So say you've got like four people, Andy, Bob, Charlie, and Danny, right? And Evan, so five people, right? And the problem wants you to kind of output all the different ways that they could be standing in a line. How would you store them? And yeah, Arthavan said use the list. And yeah, you would have to use a list to store these because the thing is, defining isn't like as like, brainless or simple as you might think because sometimes it really is important how you store the information early on. And although right now it's a pretty obvious example that you wouldn't want like D to be
All right, guys, it seems like maybe Yang might be having some Wi-Fi issues. We'll just wait a little bit to see if he joins back. Um, his Wi-Fi probably just cut out or something, but he should be back soon. So we'll just hang in tight for now. All right, so it seems like Yang's electricity went out, and a like a section of Windsor's like electricity went out, so our backup teacher is also not available right now, unfortunately. Um, yeah. So for now, oh, Yang's just said he thinks the power is coming on. I was just gonna say that we might have to cancel this workshop for now, but it seems like Yang just told us his power is coming back on. So maybe we'll wait like 2 more minutes and see if the power comes back on and if we can continue the workshop. Thanks for waiting, everyone. We appreciate it.
Yo guys, I think I am back now. Sorry about that. Um, so yeah, what happened was there was just a like literally just a power outage, and I think the power just came back on recently. So sorry about that, and sorry for the delay. So yeah, it's not going too smooth, but yeah, thanks for your patience, guys, and I guess we will resume now. My question is, did yeah, the participant number seems to be pretty normal. So I guess none of you guys live in my area, so good for you guys. Um, and yeah, I will try and share my screen again. Um, by the way, Lily, did the YouTube thing, like, is it still live? Yeah, like, yeah, okay, it is. Because I just saw it says live on custom streaming service, so that should be fine. So I will try and share my screen. And right, we'll get right back to it. So we when we cut off last, it was on Danny and Bob. So yeah, I had declared a list with Danny and Bob inside, and I was just talking about how it's not a good idea to do this, but it's a fairly good idea to do this because this will help keep all your information in one place and you will be able to access it. And another great thing is if you write a for loop, your for loop will be able to go and access, Danny and Bob, but it won't be able to access D and B because, just as two separate variables, they don't have any real relation to one another. So you can't really get much use out of that. All right. So, yeah, that is the defining phase, and that's, important as always. And now we'll just move on to the executing phase. And guys, don't worry. Like I know I haven't coded too much to show you guys. There's not much concrete stuff, but I promise, after we run through the 4 steps, I'll show you a couple of examples and how to apply those examples. So with the executing phase, right, this is the most time consuming and difficult part of the implementation process. And here you also have the least guidelines on what exactly to do. But the good news is like the lesson at 2:30, 3:30, and 4:30, those lessons should cover some things, some ways of executing your code. So for example, using one-dimensional dynamic programming or two-dimensional dynamic programming or even graph theory. And yeah, so yeah, executing is just when you code out the solution to a programming problem. And there are still some rules of thumb though that do apply because you want your code to be understandable, optimized, and also above all else, you want it to actually solve the problem that you're trying to solve, right? You don't want it to give an incorrect solution. So now it is time to, I guess, cover some optimization as well. So in brief, optimization is when you try and make your code more efficient in the solution of a problem. And this is important because there are countless ways of coding a solution for most competitive programming problems. But most of these will not work simply because they take up more time or more space than the problem is giving you. So as a quick example, we'll do the classic, finding prime numbers kind of algorithm. So yeah, we'll solve, I guess, the question I originally posed where like Bob wants a prime number. So say the number that you start with is int input. Now you put int around the input, right? Because input always takes it in as a string, and since the problem will be giving you a number, you want to work with a number, so you transform it into an integer. Yes. So Krish, yeah, my Wi-Fi went out, and I was not teaching for quite a while, so I don't think you missed out on much. So yeah, you have num equal to int input. And then, so yeah, that's the number that you get in. And the problem that I told you guys about was, Bob, he wants to check if a number is prime. And if not, he wants to find the next greatest prime number. And in that case, you need to find a way to check if something is a prime number. Now, we know the definition of a prime number is that it can't be evenly divided by any integer, any natural number except for a one in itself. So we can write a quick for loop to check for that. So for k in range num, right? Now for loops always start at 0 and they go up to the num, but they won't reach num. So if it was for k in range, say 10, it would go 0 all the way to 9, including 9, but it wouldn't go up to 10, right? And this is good in our case because obviously if we're checking for whether something's a prime number, we don't want to check if it can evenly divide into itself, because that will obviously work. And that won't give us any information if it's prime or not. And you also don't want to start at 0 because anything divided by 0, that's undefined. So you might want to start at 1, but you also don't want to start at 1 because any number can be divided evenly into 1. So you would want to start at 2, and that's how you would start the for loop at first. And then you just go checking if num mod k is equal to 0. Now, oh, sorry, you want an if statement on that. So I hope you guys also know what mod does, right? So mod finds the remainder of a division statement. So you can kind of think of this statement as saying, if the remainder of num divided by k is equal to 0, yeah, if the remainder is 0, then it divides wholly or completely, and that means it is not a prime number. So in that case, you might want to print something. So just print, well, actually, in this problem, we want to find the next greatest prime number if the number itself is not a prime number. So we'll just leave a couple of indented spaces here to remind ourselves that we need to finish this piece of code. Now, here's something interesting. I actually use this a lot. So you might think that this is incorrect coding form. And yeah, there's a squiggly line under here, but if I just add something, the squiggly line should go away also if I add something here. Okay, so Replit doesn't show any error, and this kind of code actually does work. So we usually think of, using if else, right? So if something works, then the code under the if statement will run. And if that if statement is false, the code under the else statement will run. But you can also do this, which is commonly known as a for else loop. And the reason for that is because the for and the else are at the same indentation level. And whoops, this kind of stuff is actually very useful, especially in trying to find a prime number or stuff like that. So the way this works is it will go through a for loop as you think, and it would check the if statement. And if the if statement is okay, the if statement is technically not a major part of this. Usually it will involve an if statement, but it's called a for else loop, not a for if else loop, because the important thing is just the for and the else. So if this for loop runs completely, so if it goes from 2 up to but not including num without any problems, without breaking, without throwing an error, then it will do the else statement. But if it does like break during the running, then it will not do the else statement. So for example, we can just run this code to quickly see how this works. Okay, yeah, sorry. I may have defined it a bit wrong, but how this works, right, is because I add a break statement here, this if runs, right, and then the code breaks, so it does not go to the else statement. But if there was no break, then yeah, it would run, like however many times, but then it would also go run the else statement. So that's how a for else loop works. So it will go through the for loop, and if the for loop runs without any hitches, doesn't break, then it will run the else loop. Now, if the for loop does break, then it will not run the else statement. And this is very useful with prime numbers. So here we could just say it breaks, right? And then else, just print, well, in this else statement, that would mean that the number is prime. So you just print num. So in this case, I'll quickly like get rid of the random spaces here. And then, yeah, so I typed in 12 and it didn't give me any output. If I type in 13, it gives me output of 13. So we've just created a very like simple, I guess 5-line way of figuring out if something is prime or not using the for else loop. And this is very good because otherwise without it, you might need to use a flag or something like that. So you'd need to add another variable and you'd have to like check the variable at the end to see if like something changed or if it was or was not prime. So this saves you space, makes your code simpler. And yeah, like see in just 5 lines, we have a code for finding out if something is prime or not. But of course, the original problem that we were trying to solve was to see if to find a prime number if the original number was not prime. And in that case, we'll still have to keep the break statement because if we didn't, then you'd find the next prime number and then you'd also print num again, which you don't want to do. So a lot of the times for a for else loop, you will have an if statement on the inside with a condition and a break because you usually don't want to like run both or like have multiple things happening. You only want one or the other. So at this point in the code, we know that the number that we have is not going to be prime, right? And in that case, we just have to find something to find the next prime number. Now, there are multiple ways of doing this. You could just code up a solution right here, or you could also try and define something like a function to help you out. So I will just add in a function over here. Now, a function is, so in Python, there are lots of like built-in functions that you can use or built-in methods, like things like dot append. If you have a list, that's like a built-in method. And a function, you can define your own. So I can do def, and then I type in the name of the function. So I don't know, like next prime. And then I put in these 2 brackets, and on the inside, I can put in a parameter, and then I put in a colon, right? And in that case, I can write the code for finding the next prime. So in this case, we'll probably use a while loop because we want to, because we don't really know exactly when the next prime will be. So we'll do a while true statement, and inside the while true statement, we just, right. So we'll probably want to, and yeah, so in these parentheses, you can put in a parameter. And the parameter, you don't have to define like what kind what type of variable it is. Like it could be a variable holding a list or a set or an integer, and you don't have to write anything. So like you don't have to specify what kind of thing it is. So we'll just call it like just nu, I guess, in this case, or we can just name it n. So yeah, I kind of am breaking my rules, but n usually means a number, so I guess that is kind of an exception. So yeah, while true, you probably want to increase n by 1 because you know for sure that once you call the next prime, that like we'll be passing in num as a parameter, and since we'll be running the code here, we know for sure that num itself will not be prime, so you just increase by 1, and then after that you just do a quick check, right? The same kind of, and in this case we'll use a different like I guess variable for iterating through. So for j in range, right, to n, and yeah, we use the for else loop again. And this time, if the for else loop works, then we know that we found a prime. So in this case, we could break again. And this break is for breaking out of this for loop. But this break, the lower one, is for breaking out of the while true loop. And that's when we've actually found a prime. And we probably want to, save the number or return something. So we'd return n. And yeah, and in this case, that should hopefully work. So we can just use the function. So this is the definition of the function. And after you define something, it doesn't like automatically start working. You actually have to call it. So in here, I would just do next p num. And since we return n, the way functions work is if you return something, then the function that you call will eventually take on the value of the thing that you return. So in that case, you can just probably print that, and hopefully that should work. Well, I mean, if replit works, so we can just clear that. And if we try it with 12, oh, that's not right. Okay, yeah, it did work. So replit was just being funny there. So yeah, that's a problem with using replit. Sometimes like it gets confused, I guess. Maybe there's too many people using it. Maybe my Wi-Fi is not good. But yeah, the point is, as you can see, it worked. So that was, basically kind of solving the problem. But we can kind of go over the steps. So when I first set num equal to in input, that's kind of the definition stage and definition follows after reading. So since I came up with the problem myself, coming up with the problem is basically just the reading stage. And defining was when I set num equal to in input. And this was very useful because it gave me a starting point, so I know where to start the code. And then came the actual executing phase, right? And in this part, it's just using my knowledge to try and find a solution to the problem. And I, use the for else loop. Now here, there is a way to actually make the code a bit more efficient. And that is in the optimization stage. So optimizing is usually a part of, the execution phase, because you want to make sure that the code that you write or the stuff that you execute, that it's executed well and efficiently. So yeah, when it comes to finding prime numbers, you actually don't have to check for like every single value, because if you think about it, right, if you have a number like x and it can be divided by y and leave no remainder, then clearly that means that there's a number that you multiply with y to get x. Yeah, that's kind of confusing. So I'll probably use the name of the variables that I have here. So num is the number that we have, right? And k is just something that we're trying to divide it by. So num, if it can be divided by k and have no remainder, then that means that there's another number, hypothetically, that k can be multiplied by to become num, right? Um, this is basically just like when you have in math, like um, x times y equals z. So z divided by y is equal to x, something like that. Anyways, the point is using this piece of knowledge, we know that we don't have to check every single number, right? Because if k can be divided by something kind of relatively small, then we know there's probably something relatively big that is the counterpart to like the something small. And those two things multiplied together will give you num. So in actuality, you don't have to go through the entire thing. You just have to go to the square root of num. Now, also here, an important idea is you don't want to just like leave it with, like you want to change it into an integer because for loops don't work with a double or a kind of decimal. And I also like to increase this by one just to make sure that like, because if you square root something, sometimes you'll be, and you turn it into an integer, sometimes the number will get like kind of small. So you want to increase the number by one. And we can do the same thing over here, but instead we're using n because n is the parameter that we pass into next p. So yeah, we do this to make sure that n to the power, and yeah, so these two ellipses means to the power of, and 0.5 is the same as 1/2, and like anything to the power 1/2 is the same as finding the square root. And that's all we need. And we just have to increase this by one to make sure that we don't like mess up on any values. And yeah, that is an example of optimization right there, because we reduce the number of steps needed. And in fact, yeah, we more than have the work, I think we made it, yeah, maybe, it's like in computer programming, there's big O notation, which is a way of, kind of calculating the efficiency of something. But it's been a kind of quite a while, and I'm not exactly sure, like, if this increases the efficiency drastically, but it still makes your code faster. And there are problems out there where you have to do this in order to pass the test cases, because otherwise, you're checking every single value. And the larger that n or num gets, like the more time this saves, right? Like if you have a number with like 1,000 different ways of dividing it, doing it this way will cut down the work to like just a square root of that. So it might have gone from like O n time to O log n time. So anyways, that will sound familiar later on. But yeah. So that was all of that. And when I was running my code, that was the final step of the implementation process, which is compiling, right? And compiling is basically when you run the code and you test it. And the important thing is always to test your code, right? You want to test it several times just to make sure that it's running properly and that it actually solves the problem. So I tested it with 12 and it worked, but will it work with 14? And yeah, it does, because 17 is a prime number. Now, like sometimes when you test your code, it might not work and there might be a bug. And that's, pretty, painful, I guess. And then you have to go through your code and try and figure out line by line where the error might be. So yeah, and we can see here by using 14 that our code probably does work well, because it didn't give us 15, right? Because maybe a faulty piece of code may have thought that 15 was a prime number just because it was not even, just because it was odd. And yeah, it's always important to test. And you can even try like a big number, like I know 121 is not prime. And is 127 prime? Well, we can, I guess, check, is 127 prime? Yes, it is prime. So yeah, the code works. And then after all of this, you just submit the code to solve the problem. And yeah, the original problem was, Bob wants to see if his number is prime. If it is, just print out the number. If it's not, find the next biggest prime number. And our code does do that. So yeah, that was the implementation process, guys. I have to really apologize for like, a bunch of things, right? In the beginning, like I kind of I didn't know how to set things up. And then it was like a power outage and all that. but hopefully, you guys still, learn something. Um, the point is that, there's 4 stages to implementation. You have to read the problem well and figure out what information is important and what information isn't. You have to define your variables, right? And define them in a way so that they can be used in the program. And then you have to execute your code and make sure that it's, optimized. And finally, you just have to compile the code. So you want to run it and check for any bugs or errors. And yeah, if you want like an acronym for that, it's just RDEC, like RDEC, read, define, execute, compile. And yeah, if any of you guys, well, yeah, so if you guys go into like Massey and you guys take like calculus and vectors with Mr. Ng, he will, also mention something very similar, which is read, define, extreme value theorem and conclusion. And that's kind of where I got it from, because I realized that this kind of 4-step process kind of applies to a lot of problem solving and is useful, throughout. And yeah, that should be the lesson. So yeah, Sat will be teaching the next lesson, so hopefully it will run much more smoothly. And that one will be on dynamic programming, one-dimensional, and it should be at 2:30. So I'm going to let you guys go now. Have a nice rest of your day.